Hello everyone and welcome to this video. I'll briefly explain what the types of data are and then move on to describe how R as a statistical and analysis tool deal with data types overall. The types of data are generally categorized into two types of qualitative and quantitative. The qualitative are pretty much basically description of traits of an object. For example, color or type of car and name of cities. They don't have quantitative nature. However, there may be times where qualitative data have maybe made up of numbers. However, they are not purely numerical data. So just remember that just because a number is qualitative does not mean that it will never include numbers, but rather those numbers will not be a measurement. Those numbers will not be measurement. They're rather categories, or they're rather descriptive um, a description of traits of uh, of a value or on an object. On the other hand, we have quantitative data, which is counts or measures. Pretty much anything that can be counted or measured, they're quantitative, such as age, salary, amount of salary, height, etc. Now, quantitative data are divided into two parts, continuous data and discrete data. Continuous data are measurements that can take on any value, such as height of a person, GPA or GDP, any number that have decimals, any integers, anything that can be measured or take on any value. Or on the other hand, discrete data are not measured and take on any value. Rather, they're counts. For example, number of car a person has. We can't say that person have 3.5 cars or that person has 3.5 apples. It's rather discrete. There's not a lot of involvements of measurements in terms of decimals, or in other words, the discrete data, they don't take on any value as the continuous data do. I hope that these explanations were helpful. Let's move on to types of scale. A level of or the levels of measurement depends on how you say it. Both are correct way of describing them. Generally, in the statistical and data science uh, epistemology, the levels of measurement have been categorized into four categories. The first category is nominal measurement or nominal scale, which are categorical scales such as classifications, labels, or counts. Again, nominal, although or names as the word itself describes, it's just categories or names. But just because they're names, it does not mean that we will not have nominal values or data that do not have numbers. Sometimes we could have uh, numbers actually representing a nominal value. But overall, nominal scales are, remember, categorical scales that cannot be measured or they cannot be counted. For example, names or labels or descriptions, etc. Ordinal data, on the other hand, is although made up of both nominal and numerical data, but they are the kind of data or scale that has order to them. For example, high, medium, and low, these are three nominal values. They're names, but they can have orders to them. High, it has a higher order than medium, and medium has a higher order than low. Although they're all names, but they have numerical order to them. And same thing with first, second. These are numbers, but in addition to measurement difference between one and two, there's also ordinal difference between one and two, where the first comes in the order of ascending. First comes first, and two comes second. We also have ratio and interval. Ratio is the most common quantitative scale that has meaningful differences, and one of the most significant indicators or characteristics of a ratio interval of a ratio scale is that it actually uh, zero indicates the absence of something. The absence of the quantity is being measured. We don't have such thing as zero. We don't have an object with a measurement of zero. If something is zero, that means that thing does not exist. We can't have, let's say, a person with height of 0 inches or 0 feet. We can't have a person with the age of zero. We can't have a salary of $0. If a salary is $0, then there's no salary. If someone is zero age, then that means that person does not exist. On the other hand, we have interval, which is pretty much a ratio a scale, quantitative scale, but with the exception that there is a meaningful zero. In other words, zero indicates the presence of a quantity. For example, 0 Fahrenheit, although it's a measurement of temperature, but it does not it's zero, but it does not indicate that there is no temperature. So zero could be translated into another scale in Celsius. So 0 Fahrenheit could be such x and x Celsius. So zero in this case have meaningful presence or meaningful has meaning here. So these are the difference between ratio and interval. I hope the levels of scales or measurement were helpful. I'm going to move on to R. Remember that R follows uh, sh- um, these main generally accepted types of data or variables that are explained on the books, but they have broken them down into more like subcategories or sub data types or objects, and have have as expanded them into high level and low level data types, which I will get to in a second. But before I go there, I would like to explain what a variable is because uh, as a data analyst or data scientist or econometrics analyst, you will always be dealing with the term variable, and it's a fancy way to say to call a field or an information or characteristic. It could be a number or quantity, anything that can be measured or counted, or I can assume any different value. For example, an age can be a variable, a salary can be a variable, height can be a variable, and each of the values that fall under these variables actually can take on different values, can be counted, can be measured. So that's what variable means in terms of the conceptual meaning, and also in terms of technology, a variable is pretty much a column or a field of data wherein the values can take on any value or wherein the values can be measured or counted. So let's talk about the data types and data structures in R. There's a difference between data types and data structures. So data types goes on to construct data structures. So they're different. Remember, I personally, a lot of textbooks and literature on R breaks down data types in R into 6 categories. I just added the word high level because the data types are not only limited to these 6 categories, rather there are more categories. So I would just call them low level data types or object types. And data and objects are can be used interchangeably here because anything that we create in R is called an object. Either they're variable or subvariables or data field. So this is why I put a slash and put object, just not to make confuse in case you're uh, accustomed to the way that things are explained in R. So the first data type is character. Character variable is, again, depending on the type of background you come from. Some places they call some domain call it text, some domain call it character, some domain call it words. So in R it's called character, and character is pretty much names or nominal information. And the way we indicate it in R is, let's say I just created a new variable called name, and I put I concatenated, which means uh, put all of it into one set, and I put four names: Joe, Ahmed, Gustavo, and Avinak. And I made sure that each time I put these names, I put quotation marks so that R knows that these are actually character data. So that's one of the way to characterize character or and to register a character variable into R. We just run this one, the name, and we just saved, registered a name as a character variable here. The second data type is numeric values. Um, if I'm sure all of you know what real numbers are, but numeric values are real numbers that have either decimal values or they don't have decimal values. So in this case, let's say I will say salary, and then I'll say for these four people, I'll put salaries here. So somebody will be making 45.6, somebody else will be making 23, somebody else making 28, somebody else will be making 99. So as you can see, I actually added a decimal value here so that I can save this variable as a numeric value. Otherwise, it would have been an integer, and I explain what integers are in a second. Bingo. So the salary variable has also just been saved. So the third one is integer, and integer values are again they're real numbers that don't have decimals. They don't have anything in fractions. For example, this could be age. So somebody can be like, I'm 3.5 years old. It's you're either 3 years old or 4 years old. So age could be 22. And the way you can always, if you put the age here, you can always go and change it as an integer so it doesn't take on decimal values using as function. But for right now, I'll just add L because L is the indicator that tells R to store an object as integer. So let's say this Joe is 22, Ahmad is 34, Gustavo is 45, and Avinak is 21. And I'll put L in front of all of them so that R knows that these are actually integers. So there you go, that's also been saved. The next one is logical values. And logical values, again, these it depends on what industry or domain you come from. They're also called dichotomy or true and false. There are too many terminologies used for it, but in R they're called logical, and logical values in this case, a good example could be, let's say, gender, or let's say it could be pass or fail. Say pass, fail, and then put true. Let's say Joe pass, um, Ahmad passed, Gustavo he failed, and Avinag he passed. And save this as well. Okay, I forgot to put the C for concatenation. Right, so this is also being saved. And the fifth one is complex data, and these are the complex variables. This could be, I'll just put complex for right now. These are real numbers with imaginary parts. I wouldn't get into a lot of details about this, but there will be times where you will be using imaginary parts as part of uh, data analysis that you're doing, especially when you get involved in advanced data science. But let's say I put 3 plus um, 4i, and let me just replicate this 3 times. All right, so I think I put extra space there. It's okay. bingo, it's just safe there.
And
And the last data type is raw. Again, raw data types specifies values as raw bytes. And so you will, I don't think it would be fair to explain what the main objective of raw data type is in this short video. Just remember that sometimes we will have the need to use data types that um, will need to specify raw bytes rather than uh, actual uh, actual value. So in order to produce a raw object, you'll have to use raw to character function. So in this case, let's say um, if we were if we were to write hi and then say bye, so there will be raw bytes associated with these two characters that we can actually see if we run the variable. Oops, sorry. There you go. So these are the raw bytes associated with 48 is associated with H, 69 is associated with I, space is always 20, 62 is B, 79 is Y, and 65 is E. So these are the raw bytes associated with the values inside that object. Um, there are a couple of important functions that I would like to mention here that are very important. As I said, that it's important to categorize these as high-level data types because there are other low-level data types that actually uses the these these data types in order to construct additional types. For example, dates. Dates is a combination of integer values, or let's say factors. Most of the time, it's character values. Double is a type of numerical value. So there are a wide variety of other low-level data types that, and actually these data types are actually expanding. You know, we have had each time there's a new development in the world of data science or a new technology that comes out, then those technology actually carry with themselves metadata. So those metadata and their types will fall under the umbrella of low-level data types, which uses its foundation from the high-level data types. The function that I wanted to, especially class function is allows you to look at the class or high-level data type of a variable. For example, if you want to see what the class of name is, we can simply use a class function as it says its character. Let's say what is the salary? It should tell us. I always make a mistake with these, so I did not cannot find. Oh, I put a capital C. So it's numeric. Ages, salary is numeric. Now let's see what the class of age is. That should be integer. It's integer. Let's see what the class of pass and fail is. That should be logical. Logical. Let's see what the class of complex data is. It should be complex. This is the problem with capitalization. If you're going to capitalize the name of your variables, make sure that you use them while spelling them, uh, while you're spelling the name of the variable as accurately as possible. So complex, complex. Let's see. The last one is raw, and it should bring us raw. There you go. So class allows you to look at the specification, the class or type specification of high-level details, high-level data types. Type of is again the low level. Sometimes you have numerical numbers that actually have a type of double. Sometimes you have character high level data that you whose low level type is actually factor. So this is why I would say that it's important to understand both of these functions in order to know both the high level typology and the low level typology of an object or variable. Something else in R that's important to understand is that R has a specific data structure. Just like in Excel, there's a worksheet or matrix, and R actually there are five major data structures that need to be that one needs to be familiar with. I don't want to my goal is not to teach R or to teach the foundation or structures of data in R. Rather, it is to teach data analysis and econometrics analysis using R. Therefore, I wouldn't get into the minutia of each of these data structures, but I would say that data frame is one of the most commonly used data structure. It's the equivalent of a crosstab or a table if you're familiar with Excel. If we were to, let's say, construct a a table using these information, then we can use data frame to do that. And as an example, let's say we call it data frame one, or let's just call it table one, actually, table one. And let's say we put name of each of these variables. That will be name, age, salary. Let's say we use three of them. Press OK. So bingo, we have a table one. As you can see now, we have a table one. Just like in Excel, this will be called a table or a worksheet. I will I'll teach each of these structures as I move along, as I will be introducing data analysis models. But for right now, it's important to understand what a data frame is. I hope this video is helpful. Thank you for your time.